This particular problem will be more like the problems that you guys are going to be doing for the lesson quiz or the lesson practice problems that you'll be submitting answers to online. And so I just wanted to give you one of these. I don't have a calculator to show you right now, but I will. I'll post a fourth video which will be the calculator part of this. So if you wanted to see how to best put this in your calculator, you can do that as well. So this problem would be problem number 2 from your worksheet, problem number 2. And again, I just wanted to help you set it up just in case jumping from 2 to 4 subintervals was an issue for you. And we have the same type of thing where you're going to draw the curve. In this case, we have y equals radical x, so we should know what that looks like. And then we have the interval from 1 to 3, so 1, 2, 3. But this time, we're going to be using 4 subintervals, so it's not quite as easy. It gets a little bit messy. The problems that hopefully you can see, I didn't necessarily say you're allowed to use your calculator, but hopefully you can see those decimals there, so you are allowed to use your calculator on these problems. If you're not allowed to use your calculator, typically the numbers aren't going to be quite so strenuous like all these fractions you're going to see here in a second. But nevertheless, we're using 4 subintervals to approximate, and I challenge you right now to, if you are following along here, that you're able to rewrite this Riemann sum approximation in terms of what we're actually approximating. In other words, goal number 2, what are we actually trying to find? We're trying to find the approximate value from 1 to 3 of the integral from 1 to 3 of the square root of x dx. So if you can get familiar with that notation before we even start talking about it, it'd be kind of nice. So anyway, this is what we're approximating, and again, we are needing 4 subintervals. So we're going to have to divide our entire interval. Again, our interval is from 1 to 3. When we divide it into fourths, each subinterval has the same width. And so the first subinterval goes from 1 to 1.5, and 1.5, I'm going to write that as 3/2. Okay. We are using a left Riemann sum, so from the left-hand side of that subinterval, we go up to the curve, and we stop, and then we continue over and finish creating our first rectangle. Okay, so let's find the area of this one first. The width of this subinterval is 1/2, but the height of the subinterval would be f of 1, and f of 1 would be the square root of 1. So we have 1. So the height is 1, the width is 1/2, and so the entire area of that little rectangle is 1 over 2. Okay. Now we need to draw our second rectangle. So our second subinterval goes from 3/2 all the way to 2. The left-hand side of the subinterval is at 3/2. We go up from 3/2 until we hit the curve, finish our rectangle. Now we just need the dimensions of that rectangle. Okay, so the dimensions of the second rectangle, I'm going to use some space down here. I'm going to put a little dot right there. Maybe I should put the dot in white. I don't know if that'll be better for you or not, but the dot in white represents, what does that represent? Represents, I'm going to find the area of that. So the area of that particular rectangle is the width of the base, length of the base, whatever, multiplied by the height. And the height would be based on the 3/2 being the input, and the output would be the square root of 3/2. You can see why we were going to want to use our calculator on this. So if we want to write that in terms of maybe simplest form, let's just leave it like that. 1/2 times 3/2. Let's just do that. Okay. Now we're going to build our third rectangle. See if I can get a different color here. How about this color? Our third rectangle is the subinterval goes from 2 to 2.5, and 2.5 is 5/2. 5/2 here. And again, our subinterval goes from 2 to 5/2, and then up from the left-hand corner, left-hand side of that subinterval, up to the graph, up to the curve, and then we finish our rectangle. You can see the top left corner of each of these rectangles hits the curve on a left Riemann sum. Okay, so now let's find the area of that guy, area of this rectangle. Let me put it down here. Got stuff everywhere here. But the area of that rectangle is 1/2, which is the length of the base, and we multiply by the height. Well, the height depends on 2. Okay, so if we put a 2 in to the function, output is the square root of 2. Okay, and now we only have one more rectangle to draw, and this does become very, very tedious. I do understand that, but nevertheless, it's a good activity, good exercise to go through and understand how we get Riemann sums. So our final interval would be from 5/2 to 3, subinterval, and then we go all the way up from 5/2, finish our rectangle, and let's figure out the area of this rectangle. The area of this rectangle is 1/2 multiplied by f of 5/2, and f of 5/2 is the square root of 5/2, because the function's value depends on the input, and the input on that one is 5/2. So putting all of this together, okay, let's see, let me give ourselves some room, and summarizing everything we just talked about, we have the area is approximately equal to the sum of the areas of all 4 of those rectangles. And so the first rectangle had an area of 1/2. The second rectangle had an area of 1/2 times the square root of 3/2. Third rectangle had an area of 1/2 times the square root of 2. I don't know why I put parentheses around that. Maybe I shouldn't. How about this? So 1/2 times the square root of 2, and then plus 1/2. Our fourth rectangle had an area of 1/2 times the square root of 5/2. Okay, so if I were calculating this on my calculator, I would factor out that 1/2 from all 4 of these terms. So just a little heads up, you don't have to do this. You can calculate each one separately. But I would do that, and by doing that, I get 1/2 multiplied by, and don't forget the 1 for the first term, plus the square root of 3/2 plus the square root of 2 plus the square root of 5/2. And if I'm looking at this correctly, I believe that that answer is about 2.61, and that's it. That's the approximate area. And then I forgot to look at our goal number 3. Was it an approximation was too high or too low? Well, if you look at this Riemann sum, if I had drawn it maybe a little bit better, it would be more clear. But nevertheless, none of these rectangles actually are pushed up above the curve, so they all fall on or below the curve, so there's spacing between the rectangles and the curve. So this approximation would be too low. Okay, so the approximation here is too low. And that's it for the videos. If you need me to, I said I'd make a 4th video with the calculator. I'm not sure you really need me to do that, because all the work is shown here. You can type that into your calculator. Let me know if you need help with that. Otherwise, you're going to be doing on your own. Let's see here. You will do on the Google form, I want you guys to do numbers. I'll write it down. I'll pause it and I'll write it down. So here you go. From your worksheet, the Riemann sums multiple choice questions worksheet, you'll do numbers 1, 4, 6, and 8. Go ahead and input your answers onto the Google form, and then I'll know where we're at, and I will see you in class.